Hey guys, welcome to the Level 1 MCAT 2019 paper. This is day 2's version of this paper. As usual for this video, what I'm going to be doing is going through each of the questions, explaining to you guys what you need to do for achieve merit and excellence. One of the tips that I actually give out for watching this video is that at the start of each question, pause the video, try and do the question by yourself just to see how far you can actually go through with the question, and then check my answers. Now, some questions I'll probably, if it's like a really big wordy question, I'm probably just going to go straight into working the answer, because I'm sure you guys can actually pause the video and read the question by yourself. Okay, without further ado, let's get started. One more thing, sorry, forgot this part. Some of the answers, there are more than one way to do some of these answers. And the exam schedule, as far as I checked when I did day 1, is that there is plenty of opportunities to get achieved. So yes, I might not be covering like every method that you can actually do to get your answer. But if you do find an answer and you want to check out whether that method is correct, just drop it in the comments and then I can just verify it for you. Okay, yeah, it's enough chatter. Let's get to question 1. Okay, so question 1, what we have is, we've got Marcus, when 60 is divided by my age, 12 is added to this number, this gives a result of 14. So what we're going to do is we're going to put down a letter at the moment, and we're going to call it, for example, M is my age. So following the instructions, it says 60 is divided by M, because that's what my age is, and then 12 is added to the answer. This gives a result of 14. Now, for achieved, you have to actually form this equation and solve this linear equation as well. So you can't just guess and check. It will not give you any kind of answers with that. Sorry, you won't get any grade with guessing and checking. Okay, so our first step is that we're going to get rid of that 12, and we're going to move that 12 to the other side, and we end up with 14 take away 12. And so what we get is 60 over M is equal to 2. And then at this point, we can actually cross multiply. So we're going to get 60 is equal to 2 multiplied by M. And I need to get rid of the 2 so that M is by itself. And that means I need to divide 60 by 2 to get what M is by itself. And I can see that M is equal to 30. Great, so this question right here is worth and achieved. All right, so let's go to the next question here. Okay, so our first step in this question is that we want to expand the brackets. So what we have is 6 times 2 and then 6 times minus 4y. So we're going to get 12, take away 24y, plus, then we've got 4 times 6y and then 4 times negative 2, which is going to give us plus 24y minus 8. And it's less than, we've got 4 times y and then 4 times 4, which is going to give us 4y plus 16. Now, at this point, I need to simplify the left-hand side. And I can see straight away that a couple of things here, that we've got negative 24y and plus 24y, so that's going to equal 0. So I don't really need to worry about it. And the next part is I've got 12 and minus 8, so 12 take away 8 is going to be 4. So what we have is 4 is less than 4y plus 16. My next step is bringing the 16 to the left-hand side, and when I do that, it will become minus. So it becomes 4 minus 16. And then 4 take away 16 is equal to negative 12, and negative 12 is less than 4y. Now, I want to have y by itself, so I want to get rid of that 4. I'm going to divide by 4 on the other side, which means I'm going to have negative 12 over 4. And of course, negative 12 divided by 4 is equal to negative 3. So my final answer is y is greater than negative 3. Now, I'm just trying to think if there's another way you could do this, where... Well, yeah, there is another way to do this. I mean, as long as you remember, it's only when you divide by a negative number that you have to change the sign. And right now, I'm dividing by a positive number, and that's why I don't have to worry about my sign getting changed. Now, some of you might have done it a different way, and you might have actually got y is greater than -3. That's also absolutely fine. So let's have a look at grades wise. Now, grades wise for achieved, you've got a couple of solution given as inequality. Okay, so a couple of options with achieved. So you could get achieved for expanding all the brackets. That's a really simple achieved there. Getting a wrong answer around here, like say you make a mistake rearranging, you could get an achieved. And then solving, like you forget to put the symbol here, you could get an achieved. But final answer, if it's a correct answer, will get you a merit. All right, let's go to the next question. All right, guys, so with this question, what we have is a fraction is equal to a fraction, and we're supposed to solve it. So what we're going to do is, when we have a fraction and it's equal to another fraction, we can actually cross multiply. So when we cross multiply, what happens is that I've got y plus 8 still staying in the numerator, but I'm multiplying by y plus 3, which is this here. And on the other side, I've got y plus 6, and I'm going to be multiplying it by y plus 2. So that's basically what cross multiplication is. You're just multiplying the numerators with the opposite denominators. All right, so once we have this, we need to actually expand this because it is a quadratic. So we're going to do the first, on the left-hand side, we've got y times y, which is y squared. And then y times 3 is 3y. 8 times y is 8y. 8 times 3 is 24. And this is all equal to, we'll expand this bracket again, so we're going to get y squared plus 2y plus 6y, and then 6 times 2 is 12. So simplifying the left-hand side and the right-hand side, so I've got to combine my like terms. So as you can see, I've got those two like terms there. So first off, on the left-hand side, I've got y squared plus 11y plus 24 equals y squared plus 8y plus 12. Now at this point, because we have y squared on both of those sides, we have a y squared on the left side and also on the right hand side, we can actually get rid of them, because when I bring it over to the other side, it becomes minus and it becomes 0. So we're going to leave it like that right now. So we've got 11y plus 24 equals 8y plus 12. So now I need to bring all the y's together. So when I bring the 8y across to the left hand side, it's going to become minus 8y. And then this is equal to 12. And as for the 24, I'm taking it to the right hand side, so it becomes minus 24. So 11y minus 8y is 3y. And then 12 take away 24 is negative 12. And I'm going to get y is equal to negative 12 divided by positive 3. And of course, this gives me an answer of y is equal to minus 4. So, grades wise, expansion and arrangement of both sides, ignore any denominator, expansion and arrangement of both sides. So, consistent solution. Okay, so I'm probably thinking like somewhere around here for an achieved, for expanding the brackets. If you get a wrong, you make a mistake and you get to the wrong answer, you could get an achieved as well. The final answer is going to get you a merit. Alright guys, let's go to the next question. Now, as mentioned in the day 1 paper, when I actually did this, the Tuesday paper, pretty much looking at this, you're thinking, why am I seeing graphs in algebra? Well, they're both connected, right? I mean, it's just algebra, it is graphs and graphs is algebra. So in this way, in this particular question, in this question, what we have is we've got a parabola and a straight line meeting up with each other. And the question is actually asking us find the x values of the 2 points where the 2 graphs intersect each other. So this is the 2 points where they're actually intersecting. But the only thing that they're caring about is what is the x value. Alright, so what is the x value there and what is the x value there? So to figure this out, all you have to do is you have to put the equation of the straight line, which is this right here. So that's the equation of the straight line. And you actually put it equal to the equation of the parabola. And when you do this, you can actually find out the 2 points that they meet. So imagine doing simultaneous equations with 2 lines. Pretty much the same idea, except in this one you've got a straight line and a parabola. So what we're going to do is we're actually going to write up this two equations, but we're not going to write it with the y. We're just going to write 7x. Actually, I might write the, oh no, that's fine. We're going to go 7x minus 15, which is a straight line, and then it's equal to 10 plus 12x minus 6x squared. Now the reason I can't actually put it equal to each other is, terrible color, it's because of, no, that's not going to work as well. No, that ain't going to work as well. Sorry guys, just trying to find a right thing, but let's just do it this way. Because both of these things here are y, and because they're both y, we can actually put both of those equations equal to each other. Because once we do that, then it's just a matter of rearranging and solving the equation. So we've got negative 6x squared. Now I hate working with x squared coefficients which are actually negative, so I'm going to bring that negative 6, in fact I'm going to bring everything to the right hand side, and that means I'm going to bring everything to the left hand side, which means the right hand side is going to be 0. The minus 6x squared is going to become positive 6x squared. The plus 12x is going to become minus 12x. Plus 10 is going to become minus 10. Now as for the 7x, which is still on the left hand side, and the negative 15 is also on the left hand side. So looking at simplifying these, so I've got to collect all the like terms, which is negative 12x and 7x. Then I've got negative 10 and negative 15. So when I put this all together, I'm going to get 6x squared. Negative 12 plus 7x, I'm going to get minus 5x. And I've got negative 10 and negative 15, which equals to negative 25. And all of this is equal to 0. So what I've got here is one of those ugly quadratic equations, and I need to factorize it. Now, so I'm just going to kind of go through with this, guys. If you don't know how to do this, actually, that's what I remember. If you don't know how to do this, go check out the videos that I've actually put up on the tutorials dealing with quadratics. There's a few ways of how to factorize it. The one I like to use is basically I do this. I go 6 times negative 25, which equals negative 150. And I'm basically looking for two numbers that are going to multiply to negative 150 and add up to negative 5. Because at this point, what we're looking for is two numbers that's going to multiply to negative 150 and also add up to negative 5. Now, in this case, we're going to get negative 15 and positive 10. Because what you should notice is that negative 15 times 10 is negative 150, and negative 15 plus 10 is negative 5. So what I'm going to be doing is I'm going to be replacing the negative 5 with negative 15 and 10. So in other words, this now is going to look like this, where I've got 6x squared minus 15x plus 10x minus 25 is equal to 0. So once I get this, I am going to split them up into 2. I'm going to factorize the left-hand side. So on the left-hand side, I can see that 3x is a common factor. So I'm going to get 2x minus 5. And then on the right-hand side, I can see that 5 is a common factor. So I can actually get down 2x minus 5 equals to 0. So at this point, you guys can see that we actually have both of these things are common factors, so we can actually take them out. And we're going to get 2x minus 5 multiplied by 3x plus 5, and this is equal to 0. So if you're wondering where that 3x came from, it's there, and then the 5 is there. So that's where they came from. Okay, so once we got this, now we can say that both of these are equal to 0. So we can say that 2x minus 5 is equal to 0, or we have 3x plus 5 equals to 0. So rearranging this, we're going to get 2x is equal to minus 5. And then we're going to get x is equal to minus 5 divided by 2. As for the other situation, we're going to get 3x is equal to minus 5. And then x is equal to minus 5 over 3. Okay. Yep, just realized my mistake as I was kind of going through it, that 2x should be equaling positive 5. not minus 5. Sorry, right there, I made a mistake. That's all right, just going to get rid of that minus. So my two answers that I'm going to get is x is equal to 5 over 2 or negative 5 over 3. And if I go to my graph, that is kind of making sense because you got 2 point, what is it? Yeah, it's like you've got one on negative, one on positive. Yeah, that looks good. All right, so grades wise, we're looking at equation formed by simplifying to a quadratic equation is an achieved. So getting up to here, you're looking at an achieved. And if you make a mistake with the quadratic equation, but you factorize it correctly, you can get an achieved. Wrong answers here could get you a merit, but getting the final two answers is going to get you an excellence. You can also get a merit if you manage to factorize right here. All right, so let's go to the next question. All right, guys, so with this question, what we have is an equation of a straight line is passing through these 2 points, and it's given by this. So we got to try and figure out what G and H is. All right, now the first thing to kind of have a look at is kind of understand that you've actually got 2 points here. So if you want to think about it like this, your first point is x1 and y1. All right, I've colored it in green. Then you've got x2 and y2. All right, that's your second point. Now, this question, there's actually 2 ways of doing this particular question. So the first method, I kind of did this similar question like this in day 1 of 2019 paper. So that's actually using simultaneous equations. So if you guys want to learn how to do the simultaneous equations, go down there in the 2019 paper and have a look at this similar type of question. Because in this video, I'm going to show you guys how to use a different method. All right, it still works. Okay, so the first thing to understand is that your equation of a straight line. Now, when you think of an equation of a straight line, you know that that's y equals to mx plus c. And having a look at this particular equation here, what we have here is hy is equal to gx plus 3. So I want to write this in a format of y equals mx plus c. So that means I've got to get rid of the h, and I've got to actually do gx plus 3, and the whole thing is divided by h. So then I can say that y is equal to g over hx plus 3 over h. And what I'm hoping you guys can see is that the m, the gradient m, is the same thing as saying g over h, and the value for c is 3 over h. Okay, so if that's the case, then what we could do is we could actually use these points here to try and figure out what the gradient is. Because remember, for gradient, we've got m is equal to y2 minus y1 divided by x2 minus x1. So that's the, it's rise over run, right? So what I've got here is, if you can look at it, y2 is negative 8, because that's what I wrote in that light blue color there. So I've got negative 8, take away y1, which happens to be negative 3. And the whole thing is divided by 7, which is x2, minus x1, which happens to be 3. Now guys, I know this is a completely different method, so if you, once again, I'm going to say this, if you want to learn the simultaneous equations, go check out the 2019 video, but this will help you with tables, equations, and graphs, so that's why I'm kind of going through this at the moment. So going forward, we've got negative 8 plus 3, which is going to be negative 5, and then you got 7 take away 3 is equal to 4. So I've got the gradient here. The gradient is m is equal to negative 5 over 4. Cool. So if I work out what the c value is, then I should be able to actually figure out what h is. So, and that's what I'm going to do. So the way I'm going to do it is I'm going to write down y is equal to mx plus c, but I know what m is. M is negative 5 over 4. So I'm going to substitute m in there, and I'm going to end up with y is equal to negative 5 over 4 x plus c. Now at this point I can choose a point to substitute to try and figure out what the c value is. Okay, so if I was to do that, I'm going to choose, let's see, I'm going to choose the first point, which happens to be 3, negative 3. So I'm going to substitute negative 3, because remember that this is x and this is y. So I'm going to get negative 3 is equal to negative 5 over 4, and x is 3 plus c. So I'm going to end up with negative 3 is equal to negative 15 divided by 4 plus c. Okay, so rearranging this, I'm going to get c is equal to minus 3 plus 15 over 4. Okay, so kind of keep going on with this. Now negative 3 could be written as negative 12 divided by 4, because remember 12 divided by 4 is 3. So I'm just rewriting negative 3 as negative 12 over 4 plus 15 over 4 equals to c. And so ultimately what I'm getting for c is that the c value is equal to 3 over 4. All right, so, and I'm hoping that you guys can see the connections here, because if the c value is 3 over 4, then notice how I've actually said this part here, that y is equal to 3 over h. So you can kind of see that h is actually equal to 4. And it does make sense when we look at the gradient. Because if you look at the gradient, the bottom part of h, which is 4, and then if you look at the light blue, which is the part for c, that's also 4. So from here, we can actually say, I mean, if you want to kind of, you can actually, can you stop here? I would actually say, no, don't stop here. You can actually do one more step to kind of help you out with this. So what we're going to do is we're going to write this as y is equal to negative 5 over 4x plus 3 over 4. And because the 3, remember that this was the gradient, negative 5 over 4, and then 3 over 4 was the y-intercept. So what we're going to do is we're going to rearrange this so it looks like, which equation are we looking at? So it's going to look like this equation right here, hy equals gx plus 3. All right, so I'm just going to copy that down here. So it was hy equals gx plus 3. So first thing is putting this whole thing under 4, because both of these fractions have 4 in the denominator. And then we can cross multiply the 4. So we are going to end up with 4 times y, which is equal to 4y, which equals negative 5x plus 3. And now, if you look at this equation, hy is equal to gx plus 3, we can now say, therefore, h is equal to 4 and g is equal to negative 5. Now guys, this way of doing this particular question is not actually, it's not in the exam schedule, but learning how to do something like this is definitely going to help you with tables, equations, and graphs. And that is why I actually chose to do this method. Now, as I said to you before, if you want to learn the simultaneous equations way of doing this, go check out the 2019 version of this paper and find this question. I think it's the last question off the top of my head, but yeah. All right, so that's basically it for this question. And now we go to question 2. I guess before I go to that, it would help if you know what this question was. So this was an excellence question. Finding the gradient gets you an achieved for sure. And if you correctly find the value of g or h, so if you find one value for g or h, you could get a merit. But if you find both of them, then you end up with an excellence. Cool, let's go to the next question. Alright guys, so that brings us to question 2. Okay, so what we have in this question is we've got a classic substitution question. So we've got y equals negative 2. So I need to replace all the y's with negative 2. So I'm going to get 3 times negative 2 to the power of 4 minus 5 times negative 2 plus 2. Now, negative 2 to the power of 4, remember that if you forget how to do it, just do negative 2 times negative 2 times negative 2 times negative 2 4 times. So you got 2 times 2 times 2, which is equal to 16. The negative changes to a positive, so positive times positive is positive. So what we have is 3 multiplied by 16 plus 10, because negative 5 times negative 2 is 10, plus 2, and we got 16 times 3 is 48, plus 12, which gives us a final answer of 60. So end up getting a nice achieved for this question. Okay, so yeah, correct solution only for this question. Like if you don't get a 60, you don't get any grade for this. Let's go to question B. Alright guys, so what we end up happening here is we've got a classic quadratic equation that we've got to do. So we are going to do it the long-winded way. So we've got 15 times negative 4 is equal to negative 60. So I'm looking for two numbers that multiply to negative 60 and also add up to negative 4. So the two numbers I'm looking for in this case is going to be negative 10 and positive 6. Because I can see that negative 10 times 6 is negative 60 and negative 10 plus 6 is negative 4. So that means I'm going to replace the negative 10 and 6 instead of the negative 4. So when I rewrite this equation, I'm going to get 15y squared minus 10y plus 6y minus 4 equals to 0. So all I've done is I've replaced negative 4y with these two things here, because that yellow part that's highlighted still adds up to negative 4y. Okay, so the next part is actually splitting it up into two, factorizing the left hand side. So on the left hand side I've got 5y as a common factor, which means inside I'm going to get 3y minus 2. And then on the right hand side I've got plus 2 as a common factor, and I've got 3y minus 2 inside the bracket, and that's equal to 0. So at this point you can kind of see that 3y minus 2 is a common factor, so we can actually take it out. And what we left over with is the 5y plus 2, and that's equal to 0. So just to recap, the 5y came from here, and the plus 2 came from there. Now this question is solve the equation, so that means we've actually got to solve it. So we've got 3y minus 2 is equal to 0, or we've got 5y plus 2 equals to 0. So we're going to get 3y is equal to negative 2 when it goes to the other side. It's positive 2. And then we've got y is equal to 2 divided by 3. And as for the second solution, we have got, losing a bit of touch there, but it's alright. We got 5y equals minus 2. And then we're going to get y is equal to minus 2 divided by 5. Okay, so those are our two answers right there. And grades wise, if you get regardless, correct factorizing gains an R grade regardless of the solutions. Okay, that's interesting. So even if you don't get the solution but you get this part right, you can get a merit. Getting the two solutions also gets you a merit. For achieved, right, oh wow, okay, so you get achieved for that. So doing this part here gets you an achieved. Both solutions consistent with their factorizing. So let's say you do factorizing incorrectly, but you get the final answers right, you can also get achieved for it. Also guys, I would actually ask you guys to go check out the schedule for this, because again, there is quite a few things that you can actually do for getting achieved in this case. Even writing a simple bracket, even if it's the incorrect signs. Yeah, funny old questions, this one. All right, so let's go to question 2C. All right, so what we're dealing with is an exponential question here, folks. And the first thing to recognize is that you've actually got a base 5 that you're working with here. However, when you come to this number 25, it's not a base 5. So what the first step you got to do is remember that 25 is actually 5 squared. So you're going to get rid of that 25 and replace it with 5 squared. All right, so we're going to get rid of the 25 and we're going to rewrite it as 5 squared times 5 to the power of 2y plus 13 equals 5y squared. Now, because the two bases on the left hand side are the same, so I'm actually talking about this thing right here. So I've got two bases are the same, and I'm multiplying it. The powers, you've got to add them up together. because if you remember, you've got am times an, then this is equal to am plus an. So I'm going to do 5 to the power of 2 plus 2y plus 13 equals 5 to the power of y squared. Now at this point I can see that the left-hand side can be simplified as 2y plus 15 equals 5 to the power of y squared. Now once again, what's happening here is that because our bases are the same, what we can then directly say is that the powers have to equal each other. So we're literally getting rid of the 5 and just looking at the powers. The powers 2y plus 15 should equal y squared. And at this point I can see that it's turning out to be a nice quadratic. I'm going to put it as 0 on the left hand side. Take the 2y to the other side, it becomes minus 2y. Take the 15 to the other side, it becomes minus 15. So at this point I need to factorize this quadratic, and so I can see that I'm going to end up getting a minus 5 and plus 3. And of course my two solutions are going to be y minus 5 equals to 0 or y plus 3 is equal to 0. So in my first case I've got y is equal to positive 5, and in my second case I've got y is equal to negative 3. Grades, get the final answer correct, both of them, gets you an excellence. Consistently solves their quadratic equation. So let's say you make a mistake and you with the quadratic equation but you solve it correctly, you can get a merit. For achieved, you could get, for just doing this, you could get an achieved. You could also get achieved simplifying indices on the left hand side. So simplifying this could get you an achieved. Yeah, there's a couple of other options as well. Okay, let's go to the next question. This one. Okay, so this question is pretty much the same one as in the 2019 paper. So I'm going to show you guys a quick shortcut method that I end up using. It always works for perimeters, all right? And it's understanding how measurement actually works. So basically, the perimeter, instead of, I think if you look at it, the perimeter of this tile space is 192, right? So what they're basically saying is that this part right here, the pink part right here, just going around real quickly, because that's all the tile part, that part is equal to 192 meters. But here's the thing though. So instead of trying to find each of those individual sides, what you do is you treat this pink part as a big rectangle. So imagine like this. I'm going to show you guys. So this 3y plus 2 is actually going to come here. All right, it's going to fit that part right there. Then you've got the 2y minus 3 here, which is going to fit right there. Okay, and so you can straight away see I've actually eliminated, or not eliminated, I've actually moved this pink line, the first pink line, from there to there, and the second one, the 2y minus 3, it's going to go there. So I'm actually going to rub out those two pink lines. That's right, I can't do that because I've actually did it as one diagonal thing. Okay, that's fine. We'll play it the old-fashioned way. So what that means, so I hope you guys can see that I've actually moved the pink line from inside to the outside. And I'm going to do the same thing here with the y. So see how this part is y right here? So I'm going to move this pink part to there. And so if I was to do that, now it's going to work. So that part is actually gone there. And as for the 4y, let me see, I need a different color. The 4y, I'm actually going to move it down here. So I'm going to cut that pink part and put it in the bottom here. Okay, so what you should see now is you've got a rectangle. A pink rectangle is what I'm looking at. Now that pink rectangle looks like this, where this is 10y plus 5, and this is 5y plus 1, and we just know that the whole pink thing adds up to 192 meters. So we've actually got two lots of 10y plus 5 plus 5 2 lots of 5y plus 1, and all of that is equal to 192. The reason I got 2 of them is because remember, the first side is here and then the second side is there. And as for the 10y plus 5, the first side is there and the second side is there. So now I've got a nice linear equation set up. So I'm going to expand the brackets. So I've got 2 times 10y and 2 times 5, which is 20y plus 10, plus I've got 2 times 5y and 2 times 1, which is going to give me 10y plus 2, which equals 192. So collecting all the like terms, I've got 20y and 30y, which is equal to, 20y and 10y, which equals to 30y. And I've got 10 plus 2 right there, which is going to equal 12. And all of this is equal to 192. Starting to make sense now. 30y is equal to 192. Take away 12. And then 30y is equal to 180. Y is equal to 180 divided by 3. And so I can say that y is equal to 6. It should be 30, not 3. And I believe that's what I'm supposed to find. Yep, I'm looking for the value of y, and I've actually shown how to get that. Y is equal to 6. Now, this question here, correct solution showing algebraic procedures, gets you a merit. In terms of achieved, setting up the equation gets you an achieved, and then correct solution, consistent solving of the perimeter equation. So even if you make a mistake with that and you get to an answer, you could potentially get an achieved for it as well. All right, so let's go to part 2 of this question. Alright guys, so for this question, what we have is we've got if t equals this, find an expression for the area of the tile space. Now the tile space is all of this thing right here. So to figure out the area for this, what we're going to do is we're going to take the big rectangle here, which I'm going to make it the yellow rectangle. We're going to subtract the blue rectangle, and we're also going to subtract the green rectangle, because when we do that, we're going to actually end up with the tile space. So what we're going to do is, so I'm going to just kind of put it up here. So we've got yellow rectangle, take away blue rectangle, take away green rectangle. So the yellow rectangle's base and height is going to be 10y plus 5 and 5y minus 5y plus 1. So we've got 10y plus 5, that's the base. And then the height is 5y plus 1 minus the blue, that's the carpet. You've got 2y minus 3 multiplied by 3y plus 2 minus the green is y multiplied by 4y. Lovely, I'm out of space here. That's alright. I'm just gonna have to try and figure this out. Give me 1 second, guys. Okay, so what I've done is I've just kind of moved this equation here, and we're gonna start messing around with it. So what we've got to do is we've actually got to expand the quadratic first. So kind of going FOIL. So we're going to go 10y times 5y and then 10y times 1. And we're going to do these things right here. So 10y and 5y is 50y squared. 10y and 1 is plus 10y. 5 and 5y is 25y. And then 5 times 1 is 5. Then we have minus. Now I'm going to put this whole thing in a bracket. So I've got 2y. So I've got 2y times 3y and 2y times 2. So that's going to be 6y squared plus 4y. And then I've got negative 3 times 3y and negative 3 times 2. So we're going to get negative 9y minus 6. And then we've got y times 4y, which equals 4y squared. Okay, so simplifying this, we've got 50y squared, then we've got 10y and 25y, which can be written as 35 plus 5 minus, I'm still going to leave that bracket in there because I actually want to get rid of the 4y and minus 9y and rewrite that as negative 5y minus 6, and I've got minus 4y squared. So now I want to take that 50y squared and 4y squared. I want to get rid of that actually. Let's do that. So 50y squared, take away 4y squared. I'm going to end up with 46y squared plus 35y plus 5. And I've got, now I've got to deal with this minus, right? So I got negative times negative, negative times 6y squared, negative times negative 5y, and negative times negative 6. So the symbols are going to change. So I'm going to get minus 6y squared plus 5y, and I'm going to get plus 6. So simplifying this, I've got two y squareds. I'm going to collect those like terms, and I'm going to get 40y squared. Then I've got 35y and 5y, which is going to give me 40y. And finally, I've got my two numbers, which is 5 and 6, which is going to give me 11. So this is where I've got up to so far. But if I actually go back to the question actually says if t is y squared plus y plus 1. Okay, so I'm just going to write that y squared plus y plus 1. So t is this. And I need to give my final answer in terms of t. All right, so because t is that, what I could do is, how do I do this? I'm actually going to write, because I can see this, right? I can see this pattern here. And this is how these kind of questions actually, you can kind of do these types of questions with, how do I say it, like kind of thinking slightly differently. It takes a while, but it's having a look at this. See how this is y squared and you've got a y squared there. Next thing is you've got a y there and you've got a y there. But the problem is the number. The number is not matching up, right? So what you could do is you could potentially do this. So you could actually say 40 times t, because 40 times t is going to look like this: 40y squared plus 40y plus 40. All right. So if we actually can get this part in here somehow, then we can replace that with 40t, because that's going to be in terms of t. So now having a look at it, there's 11 there, right? Well, I don't want 11. I actually want a 40 there. So what I could do is I could rewrite this as 40y squared plus 40y plus 40. But I want it to be 11, so I can actually write that as 29, because 40 minus 29 is actually equal to 11. So I can, instead of writing 11, I'm going to write it as 40 minus 29 there. Because once I do that, now what I could do is I could replace this entire 40y squared plus 40y plus 40 with 40t. So rewriting this, I'm going to get 40t minus 29 as my final answer. Hopefully that actually made sense, guys. I might have done it slightly different in the 2019 day one version, so have a check. Do check it out. But anyway, grades wise, we are looking at an excellence grade for the final one. Even if you get the wrong answer right at the end, you could get a merit for it. Simplified quadratic gets you a merit, so that's somewhere there. For achieved express, setting up this could get you an achieved. Expanding a couple of brackets gets you an achieved, and a couple of other things as well. Cool, so that's basically it for this long-winded question. Let's go to the next one. So question 3a part 1, guys. What we have is we've got a nice rearranging question. So we want to rearrange so that d is by itself. So what we're going to do is as always, we're going to write down this equation first, get rid of the 2f to the other side, which means it becomes plus 2f. And now that's equal to de squared. The next thing is getting rid of the e squared, so I'm going to write down as g plus 2f, and the whole thing is divided by e squared. And now this is equal to d. So that's basically your expression for this particular question. Starts off with a nice achieved. All right, let's go to question part 2. Lucky days, we've got another rearranging question. And in this case, we're actually asked to give the equation for z. So we want to actually bring z by itself. And right now, you guys can see there's actually z here, but it's actually z squared, all right? So that's something to keep in mind. So what we're going to have to do is first bring all the z squareds together. So we've got jz squared minus 16x squared equals 5y squared plus 25wz squared. So my first step is shifting. I'm going to shift the minus 16x squared to the right hand side, and I'm going to shift the 25wz squared to the left hand side. So what that means is I'm going to get jz squared, and I'm going to get minus 25wz squared, and now that's equal to 5y squared, and I'm going to get plus 16x squared. All right, so far so good. Now I need to figure out a way to get the z squared by itself. All right, and the way I'm going to do it is, because the z squared appears in both of these terms, I can take it out as a common factor. So it's going to end up looking like this: z squared bracket j minus 25w is equal to 5y squared plus 16x squared. And then, of course, I can actually get rid of the entire bracket by dividing it on the right hand side. So it'll look something like this: j minus 25w. But of course, remember, the question's actually asking you for equation for z, and right now we've got it as z squared. So what we're going to do is we're going to square root. So we're going to end up getting z is equal to square root of 5y squared plus 16x squared divided by j minus 25w. Now, really important, guys, that you don't actually square the y squared or 16x squared or anything like that. Just leave it as it is. You're good to go for now. It's only when this symbol right here is multiplication you can do that, but right now you don't have to do anything. Just leave it like that. And also, a good habit to have is that when you have square root of a number is to put a plus or minus in the front of the square root symbol. Now, the answer schedule does say it's not required, but in level 2 you will need that plus or minus, so might as well start practicing it for it right now. Grades wise, we are looking at an excellence grade for the final part of this answer, factorizing of z squared terms. So if you were to do somewhere here, you could potentially get a merit, and then if you make a mistake and if you kind of carry on, you also get a merit as well. One value both terms. Wow, really? Sorry guys, I'm just trying to read. Okay, so for achieved, you could get achieved here when you actually rearrange the z squared being on one side of the equal sign. So yeah, really interesting little excellence question, but yeah, not a bad one. Okay, let's go to the next one. Possibly one of my favorite MCAT questions, and I know a few years back, this was actually probably many years back, 2014, this type of question was an excellence question. Now it's dropped to a merit. But anyway, so how do we do this? One of the most common mistakes I see kids doing in this particular type of question is that they see the y squared, they cancel it out, they cancel that out, and they end up with an answer of -5 or 5y or something really strange. So whenever you see a question like this, just remember, you're gonna have to factorize the numerator and the denominator. So looking at the numerator, what you can see is you've got 5y squared minus 25y. 5y is a common factor. So you can rewrite that as y minus 5. And then if you look at the denominator, you got difference of two squares. So that means you got y minus 5 and y plus 5. And at this point, you can cancel out both of those two things, and you're left over with just 5y divided by y plus 5. The reason I say this is one of the most nice questions is because just doing that last part there gets you a merit. Achieved is doing either that or that gets you an achieved. Yeah, one of my favorite questions that got dropped to a merit, but it is what it is. Alright guys, let's go to question C. Okay, so writing this as a simplified single fraction is what we're trying to do here. And you know, most people actually end up doing this thing with cross multiplication. They just go, yep, I just cross multiply and it's all good. While in this case, yes, cross multiplication does seem to work, so it is a nice little example. But I always kind of look at the denominator and see what's the lowest common multiple and then go from there. But in this case, it doesn't matter because, you know, those two numbers, even if you cross multiply, you're still going to end up with the same thing. So what I mean by that is, so 5 and 4, lowest common multiple is 20. So I'm going to multiply the denominator by 5 and the numerator by 5 for the right hand side. And for the left hand side, I'm going to multiply by 4 in the denominator and 4 in the numerator. So when I do this, I'm going to get 4 multiplied by 10y minus 2 plus 5 multiplied by 4y minus 5. And of course, now that I've made the denominator to be 20, I can rewrite that. And the reason I got 20 is 4 and 5, 20. So that's how I'll get my denominator of 20. So expand the brackets. So I've got 4 times 10y and 4 times negative 2, which is 40y minus 8, plus I've got 5 times 4y and 5 times negative 5. So I'm going to get 20y minus 25, and that whole thing is over 20. So collecting my like terms. So my like terms, I've got 40y and I've got 20y, which is going to equal 60y. And then I've got negative 8 and negative 25, which is equal to negative 33. And of course, all of this is over 20. So looking at grades, merit for this particular question here, and achievement, correct arrangement for numerator does not need to be simplified. So arrangement, so probably thinking, doesn't say about expanding. I'm thinking maybe here it's an achieved or the line above. And then if you make a silly mistake from your simplification, you can still get an achieved for that as well. Cool, let's go to the next question. Okay guys, so for this question what we have is find the value of w so that the area of the right angle triangle is the same as the area of the rectangle. So what we have is we've got rectangle equals the area of triangle. Now for the rectangle we've got base times height. For the triangle we've got half times base times height. Looking at the rectangle, the base is going to equal to 5w minus 14, w being the height. Base for the triangle is going to be 4w minus 4, and h, the height of the triangle, is going to be 3w minus 8. So we're going to set up our equation right now, and what we have is 5w minus 14 multiplied by w equals a half multiplied by b, which is 4w minus 4, and height is 3w minus 8. So we've actually set up this equation, and now we just need to expand, rearrange into a nice quadratic, and solve it. So let's do it. So the first part I'm going to be doing is I want to actually get rid of this half, right? I really don't like dealing with halves. So I'm going to take this half and I'm going to multiply it with this bracket here. And when I do that, I'm actually going to get half times 4w is 2w, and half times negative 4 is negative 2. It's much better. Get rid of that. And we're still going to leave this 3w minus 8 here. And then on the left hand side, I've got w times 5w and w times negative 14, which is going to give me 5w squared minus 14w. Cool. So the right hand side, I've got to expand the quadratic. So I've got to go 2w times 3w, 2w times minus 8, which is going to give me 6w squared minus 16w. Then I've got negative 2 times 3w and negative 2 times negative 8, which gives me negative 6w and plus 16. So what I have is 5w squared minus 14w equals all of this. So I'm still going to leave this here on the left hand side because I want to actually simplify the right hand side first, and I've got minus 22w plus 16, and now I want to bring everything to the right hand side. So minus 22w plus 16, and bringing over 5w squared is minus 5w squared and plus 4w. Just get this strange feeling that I've done something wrong somewhere. I think I know why. I forgot that it's actually 14w and not 4w. Simple mistake, hey. Okay, so we're going to simplify this thing right now. So we're going to collect our like terms. So we got 6w and minus 5w squared is just going to be w squared. Then we've got negative 22w and 14, which is going to equal minus 8w, and we've got plus 16. And if you keep going, well, we've got a nice quadratic here. So we're looking for two numbers that multiply to 16 and add up to minus 8. That's minus 4 and minus 4. And so we can say that w minus 4 is equal to 0. Therefore, w is equal to 4. And I think that's what the question was asking for, asking us to find the value of w. And we have actually done that. Okay, so grades wise, we are looking at an excellence for finding the w, consistent solutions from the quadratic equation. So if you get a wrong quadratic equation but you're getting two answers for it, you could get a merit. For achieved, forms equations for both areas. Really? Wow. Just that, writing two equations for the area of rectangle and triangle gets you an achieved. That's a pretty easy achieved mark. And yeah, so there's like a few other bullet points there, guys, like for expanding your quadratic, simplifying and things like that. So again, lots of opportunities to actually end up getting achieved. Alright guys, that's basically it for this video here. As mentioned before, make sure you attempt every question possible in the MCAT, because you never know what you're gonna get an achieved for. Definitely do not leave the paper empty at all. And as always, if you have any questions or just comments about this particular paper, just drop it in the comment section below and I will try and get to you. Lastly guys, don't forget to like this video and share this video. There are a lot of people that actually don't know this resource actually exists, and subscribe to actually keep up with the latest content and also when the live tutorials are on. Cool, that's it from me, and as always, thank you for watching.